Okay, so fair warning, I've spent a while trying to find a place that I could work that didn't have kids, running around and yelling in it. So now I'm in the corner next to the printer that apparently has to be used almost constantly on this day. So I will do the best I can. Um, so this is the notes that we used in the seminar where you were given all the formulas here. So sum of squares for the total, you sum the squares of each guy compared with the total average. So this is the average where you would take every single number and add it up and divide by how many there are. And then you square each one and add them up. The sum of squares between is take the mean of each subgroup and compare it to the mean of the whole group and square that. And then each time you multiply by the number there were in the group, because we're kind of weighing it. So if one group is 15 and one group has 30, then we want to have it twice as represented. So you multiply by the number that there are. SS within, sum of squares within, is where you take each element and compare it to the mean of its group only, instead of just the whole group, and add that up. So in both this case and this case, it's each and every one. But because this between and within adds up to the total, you can actually, this t and this total, these are the same. If you know two of them, you can solve for the other. Okay, so remember that these were the formulas for that. And I have made a little thing on an Excel spreadsheet to put values in for the moment. I blacked out the parts we're not going to use. So now I'm using these stolen notes here. This person used this example where they have made up data on the weight gain of lambs on 3 different diets over a 2-week period. So note that none of them actually have the same number as each other. And all the things we've done, they all had the same amount. And so the n sub k was always the same. So this time it's not true. So the question of interest would be, do they gain more weight in general on one diet than they do the other one? Or maybe you want to know if they gain less weight. Normally with lambs, I think you're trying to get them to gain weight. So this is what we talked about on why you wouldn't just want to use t-tests. So if you just jump in using t-tests, you have to compare 1 to 2, 2 to 3, and 1 to 3. All, right? So you have these multiple things. But what happens is you're ramping up your error. So if I run a t-test with 5% as alpha each time, then I've got 5% chance of a type 1 error on the first comparison between 1 and 2. I have 5% chance of type 1 error between 2 and 3. I have 5% chance between 1 and 3. And really, there's some intersection. I might have messed up 1 and 2 and 3 with a type 1 error, for example, but that amount is actually pretty small, so you end up with very nearly 15% chance of a type 1 error if you do 3 comparisons. So the type 1 error, remember, is when you reject the null and shouldn't have. There's also type 2 error, which is built in, so we're really getting pretty hefty error possible, if we do it this way. So what we do is first we run an Anova, analysis of variance, and it tells us if any mean is different from another. So our null hypothesis is always, the null hypothesis is always all means are equal, all. So the alternative hypothesis, we don't really know, we won't just pop out with 1 is different from 2. We don't know. We just know some mean is different. At least one mean is different from at least one other mean. So then, if we reject the null, we do the post hoc test. When we do the post hoc test, we do pairwise t-tests. So that's where we go back and say, okay, well, which one was different? 1 to 2, 2 to 3, and 1 to 3. But instead of giving each one of those a 5% chance, we do it the safe route, ignoring intersection, and say, I've got 5% and I'm splitting it between these three comparisons. So I'm going to do 0.05 divided by 3, just the 0.017. This, of course, is just a review of what we've already talked about. So I'm going to do a couple of things. You know how to do this in our studio. So I'm going to do it by hand, which you need to be able to do for the exam coming up. I'm also going to show you how to do it in a calculator, which you could use on any exam that wasn't testing you hand-wise. Okay, so I'm going to take this. That was, I think, me showing someone how the chalkboard works. Okay, so there it is. So I've got, first of all, actually, let me use Excel for this, just since I have it, I might as well. So I'm going to go 8, 16, 9, 9, 16, 21, 11, 18, 15, 10, 17, 6. Okay, so I need their means. I guess I'll move this over. All right, so there are all the means. So if I want to, I probably should give myself an extra column. All right, so here I'm going to compare this value with that mean there. So and it's going to be a sum of squares always, so I'm going to go ahead and square it. Whoa. Okay. Okay, so this is SS with N here. Now I'm going to do the sum of squares total. Oh, I guess I need first the mean. Ah. Back at 12. Okay, so the total average is 13. So this was SS within. This total. Well, SS within. Okay, so if this is SS within, I'm now going to just replace that. Then this has to be 36. So between, within. Okay, so degrees of freedom between, we have 3 groups, so that's 2. Degrees of freedom total, we had 12 total, so that's 11, which means this one's 9. Okay, so over here, these have, of course, the summing relationship. These have a dividing relationship. So that's going to be 36 divided by 2, and that's going to be 210 divided by 9. And this is going to be, I'll do 18 divided by D8. So F in this case is actually quite small. The reason F is quite small is because these are quite similar. So if the comparison between and the comparison within are not very different, then that's how you get a small f, is by this ratio being small. We don't have the p. F critical, we can look it up. It's going to be way bigger than 0.77, I can tell you. Okay, so this is doing it by hand. I'm going to take the calculator here, add lists and spreadsheet. So I'm going to put here D1, D2, D3. I'm just naming them. Don't put in here, this does a formula. So if I wanted, let me show you this real quick in case you need to do this for, say, handwork. Let's say that what I wanted was this one. Let's say I calculate the mean. So I go to stat calculations, one variable stats. And then I say, okay, so it's result over here. So I see here that the mean is 11. That's what I calculated before, but I could have used one variable stats to discover this, okay? So now I'm going to delete this all. And I guess I deleted everything, so I'll put this back. So let's say now that I wanted to find out, oh, hey, crazy. Let me just start this over. Well, I guess you need to know how to do things. I just didn't scroll back up enough. These were still there. Okay, so now let's say that I wanted to do the sum of squares for this guy. Then I can say here, this equals A minus 11 squared. And then this does it for me. So this is, you can put in a formula as you would in a Microsoft spreadsheet, but you just you don't have to copy it down or anything. You just put it in the column and say, this is what I want this column to do, and lo and behold, it does it. Okay? But we actually want it to do the whole thing for us, so let's put these all in. Okay, so now, menu, statistics, tests. Go down here, hello, to Anova, and say data. We have 3 groups, 1, 2, 3, and they are D1, D2, D3. I don't see any reason not to put this in D. Okay, so here's the F that I calculated, the p-value it gives me, which obviously would be a non-reject. The degrees of freedom between, sum of squares, between, mean square, between, the degrees of freedom within. So remember that the within is the unexplained. So the between is the bit that's explained by the subgrouping that we decide if we group it, that part doesn't count. And then the within part is the legitimate unexplained variation. Okay? So they call it error on the calculator. The error is the part that's not explained. So degrees of freedom, sum of squares, and then mean square. And then they actually give you a confidence interval as well. Okay? Whoops. I don't know why I can't use the scrolling on this thing. It's crazy. So that's how you would use these. If you were trying to fill out a chart, say, there's F, of course. And then these are between. These 3 things are between, and when it says error, that's the within. Okay? So that is how you would do this, how you would do it on a calculator, and how you would do it by hand, and hopefully this helps you to prepare and to learn.